So I welcome once again to all of you for this faculty development program on artificial intelligence, machine learning, and data science for engineering application. So as an introductory lecture, I'll tell you about some of the aspects related to the machine learning and exploring machine learning. So most of the things which I will cover in this lecture, they are two fundamental. So those who are experts, maybe they have knowledge about it. So I made this as very simple to understand to the people who is very new to these three fields: artificial intelligence, machine learning, and data science. And in fact, most of the slides, whatever I'm presenting in this presentation, they are taken from Google research. It is not prepared by me. Some of the slides I have prepared, but most of the slides I have taken from Google, and it is given very nice representation to understand the machine learning techniques, why machine learning is required, and what are the different techniques under the machine learning. So overall, you can get some idea related to some of these techniques. So in this 2-hour session, I'll start with motivation, because there are many areas that are emerging nowadays. Not only AI, ML, or data science, there are so many other emerging technologies are there in the market. And although many other technologies are available in the market, so they are relying on either some AI based technique, or if you go inside, machine learning based technique, or you can say deep learning based technique, or the data science. So we'll go for some of the motivations why actually people are interested in these topics. Then we'll discuss about the introduction part of machine learning, in which I'll tell you what is there prior to the machine learning and what machine learning actually changes in today's scenario. And then we are going to discuss about the difference between the rule-based and machine learning. Means prior to machine learning, we have rule-based system, and rule-based systems also applicable nowadays in various applications. Not necessary that all type of applications you are going to apply the machine learning. There are many applications where rule-based can provide you a solution. So we should to understand that given a particular problem, whether a rule-based system is applicable or machine learning is applicable, or both rule-based techniques also you can apply, machine learning you can apply to solve a particular problem. Then we'll go for a simple idea for its implementation. We'll see the machine learning process, and we'll see how to implement the machine learning algorithms. And it is also important to know that what machine learning can do and what machine learning cannot do. Because if you go for as an academician, I can say those people who are interested in machine learning, irrespective of their problem, they are trying to apply the machine learning techniques. So that is not a good way to do research, right? First, we need to understand for a particular problem whether machine learning is applicable or not. If it is applicable, then we will proceed for it. Okay, so what machine learning can do, that we need to understand. Followed by the conclusion and the references. So here I am showing you a hype cycle, which we called as Gartner hype cycle. And this hype cycle, what you are seeing in this presentation, it is for emerging technologies. Although it is 2021, so you can go to Google. I'll show you the latest hype cycle. You can type hype cycle for emerging technology 2023. So you will find this particular hype cycle. Okay, so this hype cycle is released twice in a year, and the latest hype cycle that is available is August 2023. Okay, and probably in the first part, like let's say in January and February, one hype cycle was released, and in the second part, in August or July, they release the second hype cycle. So you will not get the latest hype cycle, okay, because that latest hype cycle is not open source. But once a new cycle is released, you can get that old hype cycle. So if you go to this particular hype cycle, why I'm interested in this hype cycle? Because Gartner is a research and development firm which suggests various emerging technologies to the academicians as well as industries. For example, if you look into this hype cycle, you can see there are several technologies are written in this hype cycle. Okay, and you can see x-axis represents the time and y-axis represent the expectation. So again, x-axis is also again divided into 5 parts, starting from innovation trigger to the plateau of productivity. So let us understand a little bit because it is more important those who are in industry or those who are want to assign some research areas to their research scholars. So we need to understand about this particular hype cycle. So innovation trigger is same as if a new technology is there in the market, it will be in the innovation trigger. Like nowadays, we talk about also blockchain, we talk about we can say quantum computing, and we also talk about model as a service. These things you can find in the innovation trigger. Okay, and that will also releases hype cycle with respect to various technology that I'll tell you later. So innovation trigger means a technology which is new in the market and it is not explored much because nobody is aware of this particular technology, right? Then gradually, if the technology succeed and technologies provides economical solution or the technology provides some state-of-art solutions, right? Then people usually adopt that particular solution. Then it will enter to the second phase, that is peak phase. Okay, and over a period of time, the technology is going to be obsolete, right? Nobody is interested in that particular technology. And you can see several colored dots or triangles here. And these dots or triangles represent what is the life period, you can say, or when the plateau is going to be reached for a particular technology. For example, if you see there is a yellow colored triangle here, which talks about cyber security mesh architecture, although it is not a part of our course, but which indicates that this technology will be there in the market for next 10 years or more than 10 years, we can say. But if you go for neuro-symbolic AI, that is also marked also in a triangle, right? So that indicates that this technology is also sustained in the market for more than 10 years. Now, if you go if you see all this technology, maybe some of the technology you are familiar. Like nowadays, we are talking about the federated machine learning. We have a also session in our faculty development program related to federated machine learning, right? If you look into federated machine learning, it is represented by a blue color dot, which says that the technology will sustain in the market for 5 to 10 years. Similarly, nowadays, all of us are listening in various lectures related to the generative AI or chat GPT or various GPT. So if you see this one, it will be there in the market for 2 to 5 years. It is not a, you cannot strictly say that it is 2 to 5 years or 5 to 10 years. So it is an estimation or a prediction kind of thing, which may not be true. That's why I told you this hype cycle is released twice in a year by Gartner. And always we need to look into the latest hype cycle to understand the things. If you understand the latest hype cycle, the latest hype cycle will help you to identify some of the technology in which you can start your research or in which you can start the product or in which you can adopt the technology in your business process or in the market, which will help you to provide better solution compared to the traditional solutions. So that's why I have shown this particular hype cycle to you. Similarly, I'll show you another hype cycle. If you type in the Google related to hype cycle of artificial intelligence 2023, you'll get another hype cycle. Okay, but here all the technologies that you are going to get that is related to AI. Similarly, in your respective area, you try to search the technology. Like here you can see. Okay, this is related to only AI. You can see the generative AI position, okay, which is 5 to 10 years. Okay, Then you can see neurosymbolic AI, which we have seen there in emerging technologies, which is more than 10 years. Okay, composite AI, data-centric AI, AI engineering, AI simulation. Okay, these are, you can see, they are life periodic. You can say it is either 2 to 5 years or 5 to 10 years. So in your respective area, you try to find some technologies or some topic which are there in the Gartner Hype Cycle, which will help you to explore that particular area and understand a particular thing. That's why I've shown you this Hype Cycle. And you can see AI is also integrated with other area like cloud-based AI services are there, right? And also AI plays a major role in autonomous vehicle. In autonomous vehicle, we have 6 different levels, starting from level 0 to level 5, where level 0 says that there is no automation, and level 5 says there is a full automation. Okay, currently we are in level 2 and level 3. So there is a partial automation. Like, nowadays the vehicles don't have gear system. They don't have much control. The vehicle need not be much controlled by the driver. It is still controlled by the driver, but not fully controlled by the driver. Few things are automated. So when we reach to the autonomous driving system level 5, then there is no need of a driver. So simply you can choose a particular location. Your vehicle can move from your source to destination. So that is our expectation in level number 5. How, when we can reach that, it requires a lot of research and also a lot of time to reach to that particular level. So coming to my presentation, so here I am showing you oldest hype cycles, but if you go for Google, you can find the latest hype cycle. Similarly, whenever a topic is new to anyone, right? If a new topic is coming into the market, so we normally search in the Google to know about that particular technology, right? Similarly, there is a site called Google Trends. So you can type in Google now if you have with your system. So in Google Trends, once you go to the Google Trends, you can search machine learning, or I can show you here. If you go to Google, if you go type Google Trends, and if you click this one, here you can search any keyword. For example, I want to search machine learning. Okay, machine learning, then I am clicking explore. Okay, so what this site is going to tell you, it is going to tell you how many search queries are received by Google. Okay, for example, I want to select worldwide, or you can select a particular country here, and you can select a particular year here, or if you want to see the past hour, past day, past 4 hours, 7 days, or 30 days, or past 5 years, or maximum data that is available is 2004 to present. Okay, let us select this one, 2004 to present. So you will get a, I can say, a graph like this. So what it indicates, if you look into 2004, the number of search query received by Google related to the machine learning term, which is very less. However, you can see after 2016, it is increasing. Okay, and you can see the peak is reached in March 2024, that is 99. So always these values are calculated out of 100, right? Just a relative one. For example, assume that 10 billion search queries are received by Google. So that 10 billion is normalized to a relative index of 100. Okay, and gradually other values are normalized. That's why you can see it is very less before 2016, but after 2016, not about a, nowadays also in various schools also people are now interested to build some model related to the machine learning. Not only that, you can also see the countries where the maximum search query is received. For example, if you see Ethiopia is having search index of 100. Okay, I told you this is a relative index. So maximum search query are received from this country, followed by Singapore, and our country is in the third position with the relative index of 89 related to the search query. machine learning. Followed by Nepal also, you can see the search query is, although they have very less population, but the relative index is very high, followed by South Korea. And if you want to know the details related to any other country, okay, you can simply click that particular country, like Russia is having a relative index of 9. So you can go for respective countries and find what is their relative index if you are interested for it. Similarly, you can also see what are the related topics and related queries related to the machine learning. For example, you can see now people are very much interested to write Python code for building various model. They also interested on the deep learning, also the courses offered by various um, various organizations like Coursera or other platforms. And many people are also looking for cloud-based solutions, right? Like if you go for Amazon or Microsoft, they are also providing AI ML services. So you can deploy your services, you can analyze, you can do data visualization, you can analyze the data, you can also look into the number of search queries. Okay, that is the related topics. Similarly, we have related queries, that is Python, data learning, deep learning, data science, machine learning, and machine learning engineers. So these are the related queries and topics that comes for machine learning. Similarly, if you uh, go for a particular country, let us search for our country, there also you will get details related to machine learning. Like in India context, if you look, then this is the source query status. And you can see the peak is reached in March 2024. Okay, this is March, April 2024, I think. Okay. So similarly, you can see what in which state maximum source queries are generated. So you will find Andhra Pradesh is in the top position, followed by Telangana, Karnataka, Tamil Nadu, and Puducherry. They are in the first five list. Okay, top five list to source this particular search query. Similarly, you can find what are the topics and what are the related queries. If you want to compare two different technology, for example, I want to compare machine learning with data science. Just I want to know that maximum search query perspective, which technology is much more popular. So you can see, although we will not find a huge gap between the machine learning and data science. In fact, these all areas are merged when we go for engineering applications. Nowadays, many applications we deal with where machine learning is also required. You need to analyze the data, you have to do analysis, you have to do visualization. So everything comes into picture. All the technologies are integrated to provide the solutions. Okay, like that, you can compare any technology or more than two technology in Google Trend. So the main reason why I told you these uh, two, that is one is Gartner Hype Cycle for emerging technologies, and I also showed you Gartner Hype Cycle for artificial intelligence, followed by machine learning Google Trend in India perspective as well as worldwide perspective. Is that the main reason of showing this one is that this will create an interest to learn this particular subject, and you should know that what are the main technology, why these people, why this technology is nowadays referred in many industries, or many people are want to do research in this particular field. So for that reason, I have shown you a small motivation that what Gartner is given and what Google Trend is given. Now let us see a very small video. Then we'll go for the definition of what is machine learning. So I'll show you this video. Just a minute. Yeah, you can watch this video, then we'll discuss based on this particular video. Then we are going to discuss about what is machine learning. Can anybody confirm? Are you able to get the voice? Are you able to get the voice of this video?
Yes, sir.
Yeah. Okay. Thank you.
Your ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer program to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. Silly mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping and viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter, and find us on Facebook.
Yeah, this video gives a small highlight related to the machine learning. Can anybody tell what you have learned in this video, and can you define machine learning based on this particular video? Any participant? Any participant, can you define what you have learned from this particular video? So you have seen two things, okay? One is you have seen, one is dog, another is cat, right? So initially you have seen, let us focus on that example, dog and cat. You have also seen other examples like medical diagnosis or space, also space analysis also we can use machine learning. But basically what we have seen here, there is a difference between the dog and cat. But when you take 100 photos, the accuracy that you are getting is 55%. That means if the data, in a lighter sense, I can say, when the data is very less, it is difficult to distinguish which one is dog and which one is cat. Right? So if you take only 10 images and try to understand these images or extracting the features and taking a decision, then your decision may not be appropriate, right? But when you increase your number of photos to, let's say, 100 to 500, and what we have seen that the accuracy is increased, right? So we can clearly distinguish which one is dog and which one is cat. That's why people say that data is everything. Everywhere people are usually say data makes changes to everything, right? So data makes dog is equal to cat. Data also makes dog is not equal to cat, right? It purely depends on the data and the number of features that you are extracting to distinguish between these two animal. So that will give you that clear distinguish. If you are not able to distinguish using different features, then finally you can say dog is equal to cat. So that's why I asked you a question that how would you define a machine learning? So all of us know AI is a very big field, and in fact AI is not new. Those who are faculty members, they are aware that when they studied their undergraduate study, they have also took a subject called artificial intelligence. Today also students are very much interested in artificial intelligence. In fact, many IITs or if you see NITs and central universities or many private universities nowadays offering a course that is BTech in artificial intelligence. So AI, which is there from long back, in fact, you can see last century this word is there, artificial intelligence. It is not a new one, but the type of applications that we are looking in day by day, that is completely new. So AI is a very big field, you can say. Okay, inside the AI, if you go, you will find several topics. You can find natural language processing is one of the topic. Somebody can find machine learning is one of the topic. Okay, somebody can go for syntactic analysis, or you can go for semantic analysis. You can go for different type of graphs, different type of representations, propositional logic, predicate logic. These all are the part of artificial intelligence. But in the artificial intelligence basket, there is one of the popular object I can say which is there in the basket, that is our machine learning. That's why if we want to define machine learning, so machine learning is a specific field of artificial intelligence. So if you go inside artificial intelligence, you will find machine learning is a field. But there are some other fields are also there inside the artificial intelligence. So what machine learning does? A system learns to find patterns in examples in order to make prediction. So three important words we are learning here. One is called as pattern. We are not explicitly programming anything. We want to learn the pattern. Okay, for example, if I say if x1 is the input, y1 is the output. If x2 is the input, you will get y2 is the output. If x3 is the input, you will get y3 is the output. So we are not mapping x1 with y1 or x2 with y2 or x3 with y3, and we are not programming it. Rather than what we are doing here, we are finding why we are getting this y1 value for x1. That pattern we want to learn. And in order to learn a particular pattern, you need examples. For example, if I write 1 is mapped to 1, 2 is mapped to 4, 3 is mapped to 9, 4 is mapped to 16. So this is a pattern, right? So in order to understand the pattern, you need examples. Like if I give an example like this, somebody can say, let me rename it by x, rename by it y. Then what we are actually finding here, y is equal to x square. If x value is equal to 1, y is 1 square is 1. When x value is 2, we are calculating 2 square, that is 4. Similarly, when 4 is there, 4 square is 16. So we are not mapping x with y, rather than we understand the pattern between x and y. What is your input and what is your output? What pattern is converting? What is the sequence we are taking? And why we are taking that one? From that, we are going to make a prediction. For example, in this case, if I put 5 here, so everybody will say 5 square is 25. So that is our prediction. Prediction may not do also, right? Because when you go for a sequence, the next sequence may be abnormal sequence. So 5 case you may get, let's say 50, something like that. But based upon the existing patterns, okay, or existing sequence, so we can predict that if the value is 5, then we will get 25. Okay. So here the computer's learning how to do a task without being explicitly programmed to do so. For example, if I say whether a number is a prime number or not, or whether a number is odd number or not, so you can write a simple program. In fact, in our EG degree, we have written a program, very simple program. So we explicitly programmed it. Try to understand. We have explicitly programmed it. The machine learning is not asking you to do explicitly programming whatever you have done in your UG course. We are not doing explicitly writing code to do everything. It is not possible to go for this explicit programming in machine learning. But computer need to understand the patterns Based upon that, it has to give the prediction, and we are not going to write all the sequence, all the possible consequences in the form of code. So that actually define what is machine learning. Now, if I ask you, uh, is there any question related to whatever definition I have given here? Okay, if you have any question, you can stop me at any point of time. So you may think that what is a pattern? Okay, then even if patterns are there, what about the examples? And in what way we are doing the predictions? How to build a model? What is the exact meaning of explicitly programmed? Can you give an example of uh, let's say explicitly programmed and not explicitly programmed, so that we can distinguish? So these are the questions you have that I am going to address it. Then you can also see what is interesting here and what is surprising here. Some terms are interesting and some terms are surprising, right? Because that's why I told you many students or researchers, they want to apply machine learning without knowing that whether it is applicable for their research problem or not. Whether it is a disease detection or it is agriculture field or finance, everybody wants to apply machine learning to get the solution. But that is not the correct way, right? So you may get surprised that I am saying that machine learning is not applicable. On the other hand, you can see there are many applications where it is very interesting to apply. So let us start with one of the simplest example. So you can type in Google related to quick draw game. Okay, you can use this particular link or you type in Google quick draw. So let me go to Google and show you this one. Quick draw. So all of you type in your browser. If you have mobile also, you can type quick draw. Okay, let me otherwise paste this link. Okay, the site is quickdraw.withgoogle.com. Okay, you can type whatever I've said in chat box. So what it says here, can a neural network learn to recognize doodling, right? Help teach it by adding your drawings to the world's largest doodling dataset, shared publicly to help with machine learning research. It is asking you, it will going to ask a particular questions to you. Okay, let's say it is asking, draw a bus. Okay, or draw a person, or draw a pen or a pencil. Then you have to draw. Okay, so if you draw the correct one, then it is based upon your drawing. It is going to ask you. Okay, based upon your drawing, it is going to ask you, going to tell you that whether it is a pen or pencil. Yeah, is there any question? Okay, then it is by mistake. Okay, no issue. Okay, so now if I click let's draw, so it will ask you some picture. Okay, let's say it is asking something, camouflage is under 20 seconds. Suppose you don't know the meaning of this one. Suppose you are writing a circle. So
I see circle.
So it is answering, I see a circle. Suppose you are drawing a.
I see hockey puck.
You are
I
drawing
see
a
bread.
It is showing it is a bread. Okay. Suppose you are drawing a rectangle.
I see seesaw. Or cannon.
Okay. So whatever you are drawing, based upon that, it is answering you, right? Now it is asking a stethoscope. For example, I want to draw a stethoscope.
Oh, I know. It's stethoscope.
Okay, it is showing a stethoscope, right? So if you write the correct picture, then it is matching its pattern with the existing pattern. Okay, or from a set of examples, it has some design, some model, and it is checking your answer with that particular model. Okay, so based upon that, it is answering that this is a carrot, or this is a bus, this is a truck, or this is a rectangle or circle. So that type of answers you are getting in quick draw. Now, There are some questions related to quick draw. First question asks, how does the game work? Obviously, I told you we have a set of patterns and we have a set of examples, right? So based upon the patterns, or you can say examples, so it is going to predict whether a particular drawing or particular draw by a particular user is belongs to that particular picture or not, right? That is carrot or not, or it is let's say a flower or not, that you can decide. Next is, how is it recognizing your drawing? Definitely some pattern is there. Some images are priorly before it is available in the system. Based upon that, it is making analysis. And how could we program this? If you want to do some kind of recognition of various objects, so how actually we are going to write the code for it? So for this, what you have to do, you can go to quickdraw.bitgoogle.com and simply you have to write /data. I'll share this link with you. Okay. So all of you click this link. So here, if you go for, just I have added /data, nothing else. Okay. So where it is saying, what do 50 million drawings look like? So it is saying over 15 million players have contributed millions of drawing playing quick draw. And these doodles are unique data set that can help developer to train new neural networks, help researchers see patterns in how people around the world draw, and help artists creating things we have not begun to think of. Right? Everyone's drawing is not same, right? They may draw in a different way. Right? Somebody can use a pencil as a, let's say, I can say rectangle. Somebody can draw a pencil looks like a square, something like that, right? So they have collected the images of various users from various places. Based upon that, they generated this particular data set. And this data set is also completely open source, right? So those who are interested in doodling, right? So you can make use of this particular data set. Now you can see what are the images. Okay, you can see there is a aeroplane image here, right? I'm not telling you all the images. I'll tell you one specific images. You can see aeroplane here. Okay, you can see here arm here. You can see apple here, right? You can see a cell phone or mobile here, right? So if you click a particular image, right, then you can see these are the different patterns that are drawn by different users from different places. And in fact, this quick draw is having how many aeroplane images? 1,35,821 aeroplane drawings. Now you think, instead of 1,35,821 planes, if I have only 100 planes, picture of 100 planes, then you will not get better accuracy, right? But when it is increased to a very larger number, so automatically things are working. Ultimately, you can say accuracy is very low, but now accuracy is increased to a big value. Okay, or close to 100%, you can say. Right? You can see different type of pictures that is drawn by different people. From that, they have prepared a model. Okay, or they trained the model using neural network, and whatever drawing you are doing, it is mapping with these patterns. If it is matching, then it is saying that it is an aeroplane. Similarly, I'll show you another one. So for example, let us go for banana. Okay, so you can see 2,86,027. Okay, 2,86,027 images are there of banana. Okay, so many people draw different type of images. Based upon that, what you can say, whenever you are also drawing an image which matches with this particular pattern, then you can say it is an banana. Okay. So you can make utilize of these data sets to understand how does machine learning work in QuickDraw. So there is a large amount of data used to teach this game and how to recognize images. You choose any image, you choose arm or you choose banana or apple, you will find more than 1 lakh of images or 1 lakh patterns for that particular image. Okay. For example, if you take an example of carrot, so here they are saying an example of carrot, but somebody has, let's say, representing carrot just like a triangle. Okay, just like a triangle. So all, let's say, all the patterns representing carrot as a type of triangle. But if somebody is representing carrot with a rectangle, okay, it is representing with a rectangle, then your machine learning model will fail to recognize it is in carrot. That's why if you are going to describe what a carrot was to someone who had never seen before using only these images, then you have to ensure that all types of pattern or all type of things, properties related to carrot should be included in your model. Otherwise, your model will select something which is model will not able to recognize when you write a image of a carrot. Okay, so that we have to describe it. Okay, so you have to go for all types of variants, not only the rectangle variants or not only the triangle variants, all type of variants of the carrot you have to do in order to recognize it. So in this way, actually, the machine learning works in QuickDraw. Now, coming to our second discussion, I told you there is a rule-based system and there is a machine learning system. So whenever a problem is given to you, and if you want to apply machine learning, first you think of rule-based system. It is not like that all the problems you will apply machine learning and all the problems you will you will use rule-based. You first go for rule-based system. So rule-based system is divided into three parts. First one, frame the goal of the product. It says that frame the goal of the product. Like if you want to go for carrot, then you have to frame your goal as a carrot. You have to think about carrot, all different types of variants of the carrot, starting from small size to, let's say, large size. Okay, and let's say width wise also, you can say small width or medium width or large width. Then once the goal is over, then goal is decided, goal of a particular product is determined, then designers and engineers develop code and logic. Finally, you have to write code, right? So you have to look into the flow as well as the logic. And after that, you have to refine your goal until you meet your expectation. Initially, your model may not perform well, right? But if you do couple of iterations, definitely you will see your model is going to work. So first is you have to set your goal. Second, we have to develop the code. Third is we have to refine our goal until unless our condition met. For example, suppose I am saying if object.height is greater than 10. That is my first one. First condition I am putting. Let's say I want to classify a particular object. Then I am checking that whether object.height is greater than 10 or not. If yes, then do X. Right? So it is explicitly programmed. If height is less than 10, you are not able to do the X on X. Right or no? Similarly, if object.color is blue, then you have to do Y. But if object color is, let's say, red, then you have nothing to do. Next is if object.number of legs is greater than 2, then you have to do Z. So what you can see with these three if statements, these three if statements says that if the condition is true, then corresponding action is going to be executed. That is rule, right? We are framing the rule also like that. Suppose as a teacher, you have given assignment to your students. You have a deadline. You mentioned that you have to submit the assignment by, let's say, today midnight, 11:59 p.m. So if anybody is submitting assignment after 11:59 p.m. or 59 second, then it is not going to be considered. So it is explicitly programmed. Okay. So here we are not talking about if height is not less than 10, then what is going to happen? Or if color is not blue, now what is going to happen? If number of x is less than 2, what is going to happen? Less than equal to 2. We don't know because we have not programmed it. And when you go for programming, right? So a skill of a good programmer is to write all types of conditions. Okay, so it is a completely rule-based system. You have to follow the rule. If this is there, then it is going to execute. Sometimes we call it a condition action rule. If condition is satisfied, then action is executed, otherwise not. Right? But machine learning system is not like this. What machine learning models? Which part we are going to change in machine learning model? Only we are going to change this particular part. Okay, where we say designer and engineer develop flow and logic. Because if you don't want to go for explicitly programming, then this is not required. But goal still be there. Goal should be there, and you have to refine your goal until you reach your expectation. So in machine learning model, what we are doing, instead of saying designer and engineer is going to develop flow and logic, we say train a model using examples. That I told you earlier also in definition. I told you three words. One is pattern, is example. Another one is pattern, example. Another one is prediction. Okay. So for training a model, what you need? You need examples. Without examples, it is not possible to train a model. For example, as I mentioned carrot. You can see here I am showing you 10 different images of carrot. Okay, these are individual examples of carrot. Then based upon these 10 different images, I have created a model. Or I have an impression that how a carrot look like. Right? How a carrot look like we have seen based upon these 10 different images. Right? So whenever we draw images which is close to this one, any of the images, then we say yes, it is a carrot. So we have not explicitly written code. We have not written any condition. Still we are able to do. That's why model is more important. Training a model is more important in machine learning. Okay. Now, ML is an alternative approach to building the software. So, software engineering also many people are applying the machine learning. And software or program case, generally we explicitly program something, right? But in the case of model, the model may not see all types of examples, right? In real life also, if you talk about insects, we have not seen all type of insects. Okay, in every person's life, you have seen only limited number of types of insects. So when you go outside or outside country or outside your location, you may get such look different type of insect which you have never seen in your life. So their model will help, or based upon the look of a particular insect or characteristics behavior, you can see you can guess whether it is a harmful or it is not a harmful insect. That's why instead of programmer creating the rules, a model is trained with the example in machine learning. Okay. Now we are going to see what is the limitation of machine learning. Because when the data is available, that is sufficient to apply machine learning model. But when data is not there, especially those people who are working in healthcare, they always says that it is difficult to get the data because nobody is going to reveal the data. If you go to a hospital and ask their CT scan images or X-ray images, until unless you have some MOU kind of thing or some good relation, then it is difficult to get all the things. And there is a confidential things are also there, right? So ML model is only as good as the examples. If examples are there, it is good. If example is not there, then we are helpless. Like I earlier also mentioned and written here also, if all the examples are triangle, except in the case of carrot, then we are failed to recognize a carrot which is represented in rectangular set. Because our model has never seen the carrot in rectangular set. It is only seen the carrot in triangle set. That's why we can say our model is going to fail. That's why accuracy is very low. So always you can see when you try with a very small data set, our accuracy is very low. But when you go for large data sets, number of features are more, number of examples are more. That's why accuracy is increased. Then there is a question arises that what type of task do you think which would be good fit for ML? So obviously, if there is any particular example, particular application where data set is already there, and you have a very large data, then you can apply the machine learning. Okay, you can apply machine learning. But if data set is not there, so initially it is difficult to apply the machine learning model. If you apply that model, your model may be overfit or it may be underfit. It may not give your expected results also. Or overall, I can say accuracy of your approach is very, very low. Now let us see some of the examples. And I request all of you to answer to my question that whether you are going to apply the rule-based system in that case, that application, or machine learning approaches you are going to apply to solve that particular problem. So the first one which we are going to discuss, that is called as alphabetizing a list of song titles. So you know, suppose there is a set of songs you have, okay, set of songs you have, and you have, I can say, you want to order them, or you can say your mobile contact list, right, in which you want to order your mobile contact list in A to Z order, or Z to A order. Okay, normally it is in A to Z order, right? So whether you are going to apply a rule-based system, either alphabet, if you want to order them in alphabetical ways, or you are going to apply machine learning approaches. Or you can say an example, our attendance sheets also. Suppose you want to order your students' names based upon alphabetical order. So whether you need a rule-based system or you need a machine learning-based system. Yeah, Rohit sir already mentioned it is a rule-based system. Anyone who is saying it is machine learning-based system? So we have only one vote for rule-based system. Anybody? Okay, there is another vote. Sonika madam, Vinita madam. All are saying rule-based system. The reason why people are saying rule-based system is that because we know the number of alphabets, right? We have only 26 alphabets. So we have fixed number of alphabets. And even if I am writing a code, suppose I am writing a program, okay, 26 conditions if I put, or 25 conditions if I put, then I can solve this particular code. And let's say I will pick a particular song, and based upon its initials, okay, initial words, then I can sort them. So these are sorting rules or algorithms, which is best suitable for this particular task. So the answer is it is a rule-based system. There is no need to think about machine learning. If anybody want to solve this particular problem, don't apply machine learning, right? Because we have very fixed number of letters in the alphabets. But when you go for ranking web search results, ranking web search result, you know web search, right? Like I did a web search on Gartner cycle for emerging technologies. I also searched Gartner cycle for artificial intelligence 2023, right? So that is a web search. So I want to rank the web search, right? For example, based upon my query, let's say 10 pages are, there is a hit for 10 pages. There are multiple sources, you have same informations, right? So when we search, generally we got more than 1 lakh number of pages are coming, right? So you want to rank them, okay? So whether you are going to use the rule-based system or you are going to use the machine learning system. Okay. Many people are responding with machine learning. Okay, good. Anybody who is saying that rule-based system can also be applied? Again, see, I'm not saying that only machine learning is applicable or rule-based system is applicable. So based upon the type of thinking you have, you can challenge that machine learning can be applied or a rule-based system can be applied. So that's why many problems you can see, it depends upon your goal. That's why I told you the very first phase is you have to frame your goal. So based upon your goal, you have to decide, right? Based upon your goal, you have to decide that what rank value I am going to give to a particular web page, right? Or based on the goal, you have to decide whether it is a rule-based system or it is a machine learning system. So the answer is both actually, rule-based system and machine learning. I'll tell you in both perspective. Although most people have addressed machine learning, that is obvious answer. Okay, although it is, I am saying rule-based system, but normal answer is machine learning. So for example, all the websites are rated, right? We are giving a particular rating to that. Let's say 4.5 out of 5, or somebody is giving 4 out of 5, somebody is giving 1 out of 5, right? So if you look into that perspective, ranking or rating of a particular website, it depends upon how many search queries you are receiving. Okay, sometimes you can say during sale time. Nowadays, you know that the sales are going on Flipkart. So many people are visiting Flipkart, e-commerce site, right? So obviously, its a search query will be more, but normal days, the search query will be normal, right? So based upon that also, we can say machine learning is a solution. So that's why I've written it, the approach you take depends upon your goal. So are you ranking the web results based on relevance to my query? Okay, based on relevance to my query. Sometimes we know about the advanced search mechanism, right? Advanced search mechanism, we are very strict to our words. For example, I am saying only web search result. I want the search that should appear if the word is exactly web search results. Otherwise, I am not going to consider it. So if the query was news, you might also want to take into account how recently the article is posted, right? For example, posting of a particular article based upon the time. Suppose a new news came now, right? It is indexed with today's date and time. So if you go for that, then it is a rule-based system. Nothing, machine learning will not do anything. But if you want to know the popularity perspective, so whatever machine learning, whatever you mentioned, that is machine learning is correct. But if you go for with respect to time, with respect to a particular location, which is not changing frequently, there you can go for rule-based system. Like I mentioned, object color should be blue, object height should be greater than 10 centimeter or something like that. So I'm rigid about that, right? That's why I'm going for rule-based system. But when we have some dynamic nature, then in that case, we cannot capture by the help of writing code. So machine learning is an appropriate solution. Now, obviously, you will tell the answer of machine learning, but let me read the question, that is predicting housing prices based on location. I want to know what is the pricing of a particular house in a particular city. So whether it is a rule-based system or machine learning. ML only, right? Because this is varying, right? The price of a particular location is varies. There is no perfect, you can say, condition that you can put to say that it is a rule-based system. Okay. So if you say that yes, rent is fixed as let's say 15,000. Okay. Let's say it is decided by a particular community that it is 15,000. There they can you can apply the rule-based system. But there is no such rule, right? And it is not justified also. That's why machine learning is the solution. Yeah, I mentioned that there is no perfect formula for determining how much a home would cost based on its location. Because there are several factors and it depends upon the person, right? And depends upon the facilities available in that particular house. So we cannot predict it, right? By the help of rule-based system. We cannot capture it by the help of rule-based system. So this prediction is obviously require machine learning approaches. Okay, processing online payment. Every day you are doing UPI, right? Processing online, or you can say ATM. You want to withdraw some money, whether it is a rule-based system or machine learning system. Okay, so first answer is rule, second answer is machine learning, third answer is rule. Okay, now all are saying rule-based system. Yes, obviously, because it is a well-defined process, right? If you want to withdraw any amount or you want to deposit any amount, so it is a well-defined process, right? Suppose I'll ask you, finding the trending of your online payment means how much you are spending per day. Just I want to know, let's say for 1 month. In that case, you can go for machine learning because it is not constant, right? It is varying, and you want to find some pattern or trend or the way you spend. In that case, you can go for machine learning. But as I'm saying, online payment system, it is well defined by all the banks or all the UPI apps. So it is a very straightforward process. So programmer has already written some code or some applications. So they know based upon the input what they have to do. All the steps are very, very well defined. So that's why we can say it is a rule-based system. But like if I say another example, yeah, if I talk about fraud detection, right? So obviously you need machine learning. Okay, the reason being why it is machine learning, like you can see also, you might have experienced, like sometimes you want to do some transaction which is unusual. Suppose you want to pay, let's say 5 lakh rupees to someone, okay, which is very unusual, right? Let's say you maximum spend up to 50,000, but suddenly you are making a transaction which is very far, very, I can say, very high amount compared to whatever you have spent till date. So, although it may not be fraud, but we consider that it is a suspicious transaction. Okay, generally credit card case, credit card fraud detection, many people are also doing their research work. So they also find that these are abnormal transactions. And we cannot capture this one, right? We cannot capture this one. How to put a particular limit that we don't know. I cannot put a limit greater than 1 lakh or something like that because it varies with respect to person. Okay, so it is too complex and very hard to define. So ML can be used to solve the credit card fraud detection problem because we don't have any specific limit mentioned that which is going to identify there is a fraud with respect to the transaction. Okay, so I think the last one, that is classifying an object in a photo. So you are taking a particular photo and you are uploading in Facebook, and it is detecting that let's say this person is XYZ, right? It is detecting, right? Whenever we take a group photo and paste it, right? Automatically it is tagging. If tagging is on, so yes, you all mentioned that it is machine learning, right? Because if you see, there are too many variables to try and create rules for every situation. Why there are too many variables? Because sometimes if you want to capture a particular photo, the photo can be taken in different angles. Okay, like if you want to visit a particular place, historical place, then if you type in Google, so many people have uploaded their photos, right? And not necessarily that all the photos are looks like the same. They have taken different angles. So it is not that the photos are identical. So that's why rule-based system is not possible to determine, right? That's why machine learning is the solution which can build a representation by taking these pictures and identify a particular object in a particular photo. Okay, so what we have learned with these examples, 5-6 examples which we have discussed, all of you have answered correctly, that rules are defined, or I can say more or less it is static. Although it is dynamic, if you say dynamic, then you are changing the variable values every time. Okay, or you explicitly program it for that. So that's why I'm saying rules are defined. But machine learning is not based upon the rule. It is based upon the pattern. In fact, if you have trained your machine that if I'm giving the value 5, you have to give the output is 25. Right? Suppose you are giving a input is 5 and you are training your machine to give output is 25, and you are learning, let's say 100 patterns or 1000 patterns or 10,000 or million patterns. After that, again you are giving the value 5 as input, your machine may not give you 25. But if you go for a rule-based system, for 5 you will get 25 irrespective of the situation. But machine learning builds a particular model. So based upon the model, 5 may not be equal to 25. It may not be a square value. Because it is learning from a particular pattern and build a model, and the model is answering. We are not answering with respect to the sample. That is the basic difference which we have seen. And improvements come from algorithm and network in a rule-based system. How better you can write code, how better you can write logic. Okay. So based upon that, you can improve the performance of a rule-based system. For example, you have, let's say, 3 conditions, and you want to actually, somebody wants to put condition 1, condition 2, condition 3. Another person wants condition 2, then 1 and 3. Another person wants, let's say, 3 to 1 order or any order. So based on the performance is going to vary. If I'm going to put multiple condition, okay, conditions are put to eliminate something, right? And if you have studied artificial intelligence, there is a word called as pruning. Pruning says that discard the things. For example, you are in a 4 square. You are in a 4 square, and you have to decide in which side you have to go. Right? Let's say you are coming from this side. Okay, you have to decide whether to turn left or go straight or right. But you are sure that if you choose left road, you will never go to your destination. What you are doing? You are pruning it. You are not considering it as well. You have to decide only whether to go straight or to move right. Okay. So for that we have to write the code, right? You have to define a particular algorithm. You have to define a particular problem and what are the solutions. So it is a rule-based system. So it is completely fixed. But machine learning case, we want to add more and more data to improve our efficiency, or we can say accuracy. I'm not saying rule-based system is not better than the machine learning, or machine learning is not better than the rule-based system. So you have to identify which one is more suitable with respect to a particular problem. Okay. So this is one part of the machine learning. And you know, these are the very famous Google products that are available. So all are based upon the machine learning. Can anybody identify what are the products? There are 6 products, right? Can anybody identify this one? All of you know this one, YouTube. This is Google Map. This one is Gmail. Every day you are using. Okay, please identify these 3. What are these 3? First one. Yeah. First one is Google Assistant, right? There is also, universal translations we are doing. Okay, or you are speaking and based upon that it is acting, right? Then Google Translate we are using to convert from one to another. Yes, Google Translate. And third is Google Cloud. Yes. So these are the three famous products. Not only these three, all these products are using the machine learning. So in order to go these products, you need to understand what are the data inside these products, right? One of the popular one is the Google Translate. And if you go to artificial intelligence, we say universal translation. Universal translation says that one language to any other language. Okay, one language to any other language. For example, I want to convert, let's say, Tamil to another language, let's say Telugu. Okay, so there is a translation required, right? It may be available, but universal translation says that any language to any language, which is not done till now. In fact, it is considered as the top 10 problems in the world. Okay, although we have Hindi to English conversion and other conversions available, if not 100% accuracy, but we achieved with a good accuracy, I can say. But universal translation is not solved yet, so it is quite challenging. Now we'll focus on idea to implementation. Okay, what are the ideas to implement a machine learning model? So in order to implement a machine learning model, first you need to understand what is the process. End-to-end process. End-to-end process means the collection of the data to the output. All the processes are well defined. So you have to follow this particular process. First one, as I said, frame a particular goal. So here I am saying frame a problem statement. So you have to identify a particular problem and you have to decide your goal. So that is the first part. Once you have decided, for example, you want to go for, let's say, driving system, right? Autonomous driving assistance system. I can say that is ADAS, autonomous driving assistant system. So I told you there are 6 levels, starting from level 0 to level 5. Level 0 means no automation, where driver has to take care of everything. Level 5 means full automation. So driver will not do anything, everything will be done by your machine. Suppose you are interested for this particular problem. So you have to collect the data, right? You have to collect the data related to acceleration. You have to collect the data about the braking system, gear system, a lot of things. So you have to collect the data, and always the data, whatever you are collecting, the data may not be in pure form, right? Somewhere you may collect the data some related to acceleration. Somewhere you may collect the data related to different type of cars, their weight, their horsepower, their cylinders, their miles per gallon. So integration of data is very much important. Even if you integrated data, you can find the data is not in appropriate form or some data are missing. So data cleaning is one of the important part. So we call that as a pre-processing sometimes. Data collection and cleaning comes under that particular phase. And once this process is over, then we go for the process of building a particular model. Then we train the model, right? Once you build a particular model, there is no guarantee that the model is going to perform well, right? So you have to give some training samples to check that, to train that it has to follow a particular process. So you have to train the model, then we have to test the model. Okay, or you go for validations, or you took some kind of matrices like accuracy to check that whether your model is performing well or not. Okay, and if your model is not performing well, there is a feedback system. The feedback system will again back to the model building page. We'll modify the model, we'll train the model again, and again we'll go for validation, testing, evaluation, and feedback. And this process we will iterate until unless we achieve our objective. Okay, so let us understand this through a video, then we will continue our discussion.
Suppose you have a great business idea and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has 3 phases: data, modeling, and production. In the data phase, you identify the input data that your machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make. Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data. For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase. Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex. Some models classify data. Other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses. Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn from the data. Along the way, there are quizzes to check knowledge and correct any misunderstandings. In the end, there's a final exam. When training the model, you split the data into 3 sets: training, validation, and test. The training set corresponds to lessons. Here, the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data to pick up on new patterns or trends. This training could come from new data sets or from interactions with users. The system needs monitoring. This means tracking system outages, errors, data processing volume and speed, and how successfully it predicts results. Machine learning systems also require maintenance. As with any production system, this means fixing bugs, adding features that didn't make it into version 1, and the like. Machine learning specific maintenance could include testing other models and settings to see if performance improves.
So basically in this video, what we have learned that once you collect the data, as I mentioned, in the second phase, the data collection and cleaning is one of the important part. Once we collect the data and cleaning that particular data, we divide the data into 3 parts. One is training, another is validation, another is testing. Okay, and as you seen in this video, the final exam refers to the testing of the data. And not only testing will help you, sometimes we go for retesting, we are going for retesting. Multiple times we do the testing of the data and we improve the result given by a particular model. And sometimes we apply a lot of models to find which model performs the better for a particular data set. Okay, so this is the process. First, we need to focus on user, right? So maybe you are targeting, like if I say a movie recommendation system where you have to recommend a particular movie to an user, or let's say agriculture crop prediction, which crop is suitable based upon the location. Then based upon a application or based upon a business, you can focus a particular problem. So ML begins with the needs of your user and business. So that is the very first page that comes under the problem statement or deciding our goal. Then we have to define our objective, which what we want to achieve. Okay. Suppose we want to, let's say, minimize the error, or we want to maximize the accuracy of a particular system, or correctly classifying the objects. So these are our objectives. For example, predict which friends a user is likely to send a photo with, right? So although when you upload a particular photo and it is tagging your friends, so it is showing a tentative one, right? So sometimes also it misclassify, right? And you want it to correctly classify that one, right? So if you want to predict such type of things which you want to take with someone or you want to share with someone, so that will also have, for example, you are frequently sharing your photos with someone, then definitely whenever you share the next photo, automatically this that person's name is coming whenever you are sending sharing that particular photos. Okay. Or whenever you visit a new city and based upon your choice, what type of restaurant you like, based upon your type of food. Also, it is suggesting a particular restaurant, or you, if you visited a particular place multiple times. So when you go along with that particular means near that particular road or that particular restaurant, it is showing that you visited this particular place in the last month or something like that. That type of news we are getting. So that is our objective, is to give some kind of recommendations, right? And correct recommendation, I can say. Okay, how much correct, that is depends upon our model, but we are trying to give whatever data we have, based upon that we process it and suggest some recommendation to the user. And these goals are actually articulate based upon some matrices, like accuracy is a matrix, F1 score is another matrix, precision is one of the matrix, recall is another matrix. So matrix is to judge a particular model, whether a model is performing well or not, that we can decide based upon a particular performance matrix. Now coming to the third one, where you have to collect the data, because once you decide a particular idea or particular problem and objective and goal, then you have to collect the data, and it may not be possible for everyone to collect the data, right? And although we have very well-defined repository like Kaggle and others, but many domains are there where getting the data is very much difficult. So you go for generation of the data based upon the ranges also. For example, if I say that, let's say SpO2 level of a particular person, let's say it is from 80 to 100. So this is a range that is given with for SpO2. So I can generate the data using random number in the range of 80 to 100, and I can classify that if the value is close to 100, then the value is close to 100, then it's good, right? Having a good SpO2. But if the value is below 90, then the patient needs maybe a critical to a little critical patient. That type of classification I can do. Similarly, many cases we are generating the synthetic data, or if the data is not available in a particular range, and we want to make it publicly available. So if you want to generate synthetic data or your own data, make sure that you are following a particular distributions. Like in mathematics, you have studied about different distributions like uniform distribution, uh, or you studied about normal distribution, Poisson distribution, binomial distributions. So these distributions you have to follow, because this distribution will help you to generate the data. So although we have a specific session related to the probability distribution in subsequent lectures, so you can get insight about different types of distributions. Whenever a data you want to generate your own and you want to make standardize that particular data. And expert says that collecting, cleaning, and exploring and other data processes tends to the longest and the most critical part of the process. Although we expect good accuracy and we try to improve the results of an existing model, but the main important part is the collecting the data. Once you collect the appropriate data and make sure that your data is uh, correct or it is valuable, and you can get a good insights related to the data, and everything you can do by using any model. But your data is having some machine values and data is not a structured format, or data is completely in a different format, integration of the data becomes difficult, then it is really very difficult to take a decision on your collected data. Then you can see we have a training and testing model. As I already mentioned, training should be there, validation should be there, and testing should be there. So normally we split the data like I can say 70% we are giving to training, 10% we are giving to validation, and 20% we are giving to let's say testing. Or sometimes we say that 70% training and 30% in the testing process, or 80 is to 20, which can be taken as training and testing. So that in that way we are splitting the data, and we examine our model whether it is performing well or not. And you can also see here, once you predict a particular value, predict and evaluate a particular model, if your model is not performing well, then you have to again come to the data collection phase. You have to remodel it. You have to retrain your data with more data, right? Suppose you have trained with 1,000 data, then you collect more data, let's say 10,000 data, and try to fit into your model and train your model so that your model will give you better accuracy. And this process is actually repeated so many times until unless our expectation reaches to that particular accuracy, right? Or particular, it meets our expectation. We repeat that particular steps. Yeah, as per the one of the software engineer of Google Translate, he mentioned that when you go from 10,000 training examples or patterns to 10 billion training examples, 10,000 is very less in comparison to 10 billion, then it all starts to work. So data trumps everything, right? That's why based upon the collection of the data and number of samples you are taking, based upon that, obviously you can say your accuracy is good or not, right? So model you can change, you can go for number of models we have in machine learning, well-defined models. So you can change the model, but you have to see that you have collected sufficient amount of data to train your model. The more samples you will train, the better accuracy you are going to get. Then we'll see one of the important concept in machine learning, that is called as bias. So in this video, whatever I'm going to show you, here you can see bias is considered as three types. One is called as interaction bias, another is called as latent bias, another is called as selection bias. So it is a very important concept. So I'll show you this small video. So try to understand these three concepts.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool in the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation, because technology should work for everyone.
Okay, so here you have seen there are three different type of bias. As I said, one we have seen interaction bias, another is latent bias, another is selection bias. We have seen couple of examples starting with a shoe, right? So machine, your model has never seen a particular type of pattern, so it is not going to classify a different type of shoes in the category of shoe. And irrespective of the bias, human interaction is more important. Like if you go to let's say Grammarly is one of the grammar correction tool, or you go for Ginger is another grammar correction tool, or Quillbot is another rephrasing tool. So in this tool also, whenever they are providing a solutions, so there is an option that human can interfere and say that no, this is not an appropriate solution. Like there are many videos also we see in the social media sites which we can report, right? So that this is an inappropriate content which can be identified. So that can be the provider can take an actions related to that particular video. So whatever suggestions the machine learning do, it is only, I can say, it is not 100% you can say pure. So sometimes human interactions is also required to improve the performance of a machine. Okay, so when someone describes to you a new application of machine learning, so what question would you ask to them based on this video? So you may ask related to different type of biases, right? Because getting all type of patterns initially it is very difficult. That's why machine is not performing well in the initial phases. But over a period of time, we get a lot of patterns, which makes an applications to work or providing a better accuracy. Second question arises that what approaches could a software development team to take to mitigate bias in the machine learning system? And sometimes as we are dependent on the user may not give a correct information also. Sometimes we are not giving a correct feedback also. So in order to identify this one, crowdsourcing is one of the important, you can say, process nowadays, right? Like if you are aware of WhatsApp, what's my train? Where is my train? Sorry, where is my train? So there you can see, in order to know the platform of a particular train. So as most of the users are nowadays using, so they can select a particular platform. So based upon based upon the number of people who agreed to a particular platform, it is showing that 10 out of 10 persons has approved that the train is going to reach on this particular platform, right? So such type of feedback is always required to solve the any machine learning problems. So for example, like we can classify a person, like you can say when a person is having running nose, or some person is having cough, or some person is having cough, running nose, as well as temperature is there or headache is there. So based upon that, we can classify different type of fevers or flus, or you can say common cold. Right, that is one of the solution we can put. We can put a lot of conditions, right? A lot of patterns, a lot of symptoms. Based upon that, we can properly classify that, right? And we cannot also make a uniform rule that the person is having cold or not. and severity of a different type of diseases is also different, right? So you can say low, medium, high. So in that case also, it is very difficult to analyze by the help of a rule-based system. So we can go for a machine learning-based system to provide the solution. Okay, the next concept which we are going to learn, that is called as machine learning privacy. You know, security and privacy is more important. Privacy is related to the personal informations, like your password is considered as your privacy, right? And personal information should not be revealed. Because as I said that when you collect the medical data, although if you have a MOU, the hospital people may give you the medical samples, but they don't want to disclose the patient name. Okay, that is also related to the privacy. During COVID time also, we have experienced in initial phases of COVID, when a patient is detected, the patient's name, age, location, everything is revealed. So privacy is not maintained at that time. At later point of time, people hesitate to meet that particular person or hesitate to go in that particular street also. So because the personal identity is revealed, right? So later point of time in the subsequent pages, nobody is interested. Nobody personal information is revealed in the public. So we have to gather and select only data that your machine learning system need to achieve its goal. And you may not be interested in all type of features for a particular data. You may be interested only in certain type of informations, right? Like you are collecting a particular data in which, let's say, there are 30 pictures. You may not be interested in all the 30 pictures. You may be interested only in the 5-10 pictures, right? So that picture only you are going to take. You are not going to take the rest of the pictures. So obviously, if you have less data, then less you need to protect, right? If you have more data, you have to put more efforts to make it secure. Okay, but strip away data that your model does not need. Those things are not required for your model. You are definitely going to remove such type of features from your model. Although there are various laws and company policies are also there, how the data is must be kept in private. And you know, in different hierarchy also we are maintaining the privacy. Like if you talk about a particular organization, every organization has a hierarchy starting from different type of employee from lower level to the higher level, okay, or higher management. So based upon that also the privacy is maintained. And machine learning products needs to be compliant with every country it has customers and users. Because machine learning is not limited to a geographical boundary. It is not applied in a particular country. It is applied all over the world. So whatever laws and regulations we are going to apply for machine learning privacy, that should align with all the countries' policies. Everybody should agree. So if you want to enforce any rule inside a country, that is fine. But when you talk about the data is everywhere. Data is not residing only in a particular country. It may be outside the country also. Right? Normally we store our data in cloud. Like I talk about Gmail. So we don't know where is the data are stored, right? Whether it is in our country or outside. So when we talk about the compliance and laws, so in any perspective, so we need to think that it should comply with all the companies, all the countries' policies, their laws and regulations. And what ML can do, that we have to discuss now, because all the things machine learning cannot do, right? But before that, I will tell you the relationship between three different technology. As I already said, AI is a very broad domain. Inside AI, we have machine learning, and inside machine learning, we have deep learning. And in fact, data science, you can say it is a overlapping of all these three type of technologies. It is a part of machine learning, some part of machine learning, some part of deep learning, and some part of artificial intelligence as well. And if you want to go for machine learning, you need expertise in three different parts. You should have some knowledge on how to deal with a large amount of data, preferably in terabytes of data, yottabytes of data, zettabytes of the data, which is very, very huge. And you also need to focus on understand the basic knowledge of algorithms. Although some predefined functions will help you when you go for the programming languages like Python, but you should have understanding about different type of algorithms. And also you need technology, some of the latest technologies, maybe data science, maybe any other technology, emerging technologies, which requires to bring a machine learning models into a better level. Now, if you go for machine learning is broadly divided into two parts. Later, people have come up with different type of learning, but initially, you can see they are divided into two parts. One is called as supervised learning, another is called as unsupervised learning. For example, here you can see I am showing you a set of apple. Okay, not necessarily they are identical. They may be non-identical also. And I am saying that these by looking into these apples, by showing their shape, by showing their color, by saying their appearance. So I can say these are apples. So our brain understands that based upon the color, based upon the shape, based upon the other features. So this is an apple. So whenever I show another type of apple, okay, which is slightly different, okay, maybe in terms of color, maybe in terms of shapes, and maybe in terms of other things, then our brain recognizes that yes, it is an apple. It may not be, right? When we make a prediction, if the prediction may not be true. But as per our understanding in terms of size, features, and other type of uh, features, right? So we classify that as apple. But when you go for unsupervised learning, there is no level. So here I have shown a apple and I am giving a particular level that this is an apple. Okay. But when you go for unsupervised learning, there is no level, or we call that there is no teacher. Like when you go for classroom teaching, it is a supervised learning. But when you do a course in your self-study mode, you are reading a book and you are learning yourself. It is an example of unsupervised learning. So in unsupervised learning, we don't know which one is apple, which one is banana, which one is orange, which one is grape. We don't know. But what we do, we want to make some kind of classifications. For example, or segregation. I cannot say classification. I can say segregation. For example, I can say that these are the fruits, okay, or these are the objects that looks similar in nature. That's why I want to put in one basket. Or I can say these are the objects that are look similar, right? So I'm putting in another basket, and the rest of the features, rest of the objects are looks more or less similar. So I am putting in another basket. So there is no specific class level whether it is a banana or apple, right? So such type of learning is called as unsupervised learning. So there is later point of time people have come up with semi-supervised learning, which is a mixture of supervised learning and unsupervised learning. So for some, you can say samples you have the labels, but some samples you don't have any labels. Now, one of the technique, very popular technique under supervised learning, if you see, that is called as classification. So in fact, if levels are mentioned, so I can say it is a classifications. For example, I can say different type of level like apple, orange, and let's say grape. These are different type of labels I've assigned to the object. So classification becomes very easier. For example, different type of fish also. I can see their shapes and their appearance. Based upon that, I can say this is a fish belongs to, let's say, sea bass, this is salmon fish, or this is Apollo fish. I can classify it, right? That is called as a classification problem. So, for example, if you see lion case, lion is a wildlife animal, it is also a mammal. So I can, based upon that, I can do it. So that is called as classification. So there are several techniques are also there under the classification. Similarly, there is another technique under supervised learning that is called as regression, which we are going to discuss in tomorrow's class. So regression, I can say regression is more about drawing a line or drawing a curve. For example, if you want to move from X location to Y location. So if you open a Google map and searching Y location, so you may find different ways to reach Y location. But you know, the straight line from the X location to Y location is the shortest location, right? Normally, right? So regression does the same thing. You are given with set of data points, but you want to draw a line or a curve, so in which all the data points are fit to that particular line. So there are different type of regression techniques are there. I'm not telling you all type of regression technique, but We'll discuss in tomorrow's class in much detail way. There is another technique which comes under unsupervised learning. Generally, classification and regression, these are part of supervised learning, in which level is there. But if the level is not there, we are going for one type of technique that is called as clustering. Clustering is nothing but grouping. For example, I have given with let's say 90 students to you, and I want you to divide these 90 students into 3 different groups. Not necessarily they are even number, equal number of groups, but you have to divide them into 3 groups. So suppose you decided that based upon their hometown, you are going to classify. Somebody can say that whether they are male or female, based on that I can to classify into 2 groups. Or somebody can say that based on CGPA, I am going to make it 2 groups, right? So there is no specific class level here. So you can specify a particular feature and divide them into different type of groups. Similarly, there is another type of techniques that is called a sequence prediction. Right? Like in mobile phone also, whenever you are typing a particular word and it is suggesting the word from the dictionary, right? So that is a sequence prediction. And based upon how frequently you are how frequently you are using that particular word, that also possible to suggest a particular suggestion. Like somebody can write, let's say 1, 3, 5, 7, and obviously somebody will predict that the next sequence is 7. So that is one type of the technique. There is another type of technique that is called a style transfer. Like especially in many celebrations, we took photos, and later point of time we play music, and we want to we embed a particular music, and we want to play is like a movie, and the photos you are seeing with a music, right? So a music is playing in the background and the photos are moving from one picture to another picture. So that is called a style transfer. Or those people are working in the audio and videos related the things, they are also doing style transfer. Those who are doing the stenography also, they are doing the style transfer. So basically what we are doing, we are clubbing 2 or 3 things and making another thing. So that is called a style transfer. So that is also one of the techniques that people usually use to solve a particular problem. So now we will see a set of problems, and in such problems we will try to divide these. That we want to actually put that particular problem into one of the basket, which we discussed. For example, I'll show you one problem. For example, here I'm showing you recommending what someone will download based on previous purchase. Okay, so you have purchased something, right? Like if you see about Flipkart, Amazon, or any e-commerce site, so you have purchased several items, right? So now the e-commerce site is going to suggest you that which item you are going to purchase or which item you are going to download. If it is a audio or video, or which item you are going to purchase, whatever may be, right? So whether it is a classification problem or a clustering problem or a regression problem or a sequence prediction problem or a style transfer problem, that you have to guess. Okay, the first answer is regression, second answer is sequence. Yeah, you can say regression is also partially true, although it is answer is sequence prediction, because we look into the previous history and make a prediction, right? But regression is also partially true. Why? Because I can say that I am considering each and every as a points, okay, based upon their features, and I am drawing a line, right? And or I am drawing a line, and I am also going to predict something which is inclined with that particular line. But overall, if you see, it is a sequence prediction, because we look into various previous sequences and predict something. Okay. So mostly it is sequence prediction, but regression is very partially true, I can say. Okay. So it is sequence prediction. Let us see another problem. For example, labeling an email which is spam or not. All of us experienced, you know, that every day we are getting a lot of emails. Some emails are directly not coming to inbox, it is going to spam. So what type of machine learning techniques we have to use to label an email as a spam or not spam? Yeah, most of you answered classification. Yes, obviously it is true. Just like I can tell you, it is a rule-based system, right? Although not specific to rule-based system, I cannot make a particular rule. Okay, but based upon the content of a particular email, so I can apply a machine learning models and make it whether it is a spam or not. So we cannot go for a rule-based system, specific rule-based system. Although we have two levels. Okay, but dividing into two levels, we cannot put a condition. If we can put a condition, that is a rule-based system. But we cannot put a condition here. But finally, our objective is to put in one of the basket, whether we have to put in the inbox basket or spam. So it is a type of classification problem. Okay, the next one is identifying trends among a group of people who have bought a new music release. Identifying the trend among a group of people who have brought a new music release. You know that many people are involved in music, so they are releasing the music, and you want to identify their trend among a set of people. So as we are saying, group of people, right? And we are talking about a new music release. New music release indicates that already there is a set of music, means traditional musics are also there, right? And we are talking about a group of people. So the answer is obviously clustering. It is not a classification problem. Okay, because classification is normally based upon a certain classes level, but we don't know how many class levels are there. So it is not a classification problem. Similarly, it is not a regression problem also, right? Because regression, you can say it is based upon the previous releases, but not that much appropriate like previous one. Partially you can say, but not overall. So clustering is the solution. Okay, captioning a video. All of us have seen, right? Captioning, like I am recording this particular lecture, and also it is asking me that you want to keep the transcript or not. Okay, so whatever I am saying, it is written in that form, in the form of a transcript. So whether it is a classification problem, clustering problem, regression problem, sequence prediction, style transfer. Captioning a video means subtitle, I can say. Yeah, all of you are correct. So it is a style transfer only, right? Okay, the next one is determining workout activity based on phone movement. Or all of us are wearing the smartwatch, right? So I want to check everything, my workout activity of a particular day based upon my smartwatch movement or phone movement. Okay, whether your phone is moving or not, right? Movement means what? If there is, it is in fixed location, so not in fixed position, or it is not fixed position, right? That means it is changing, right? So it is in classification problem, right? Suppose I'll say if it is kept in a particular table, right? So it is in steady state, right? But if you are moving, then your position and it is vibrating, right? So I can say it is in classification problem. Yeah, some people mentioned sequence prediction. Sequence prediction means you can say, suppose based upon your one day activity, if you want to predict what is your next day activity, in that case you can go for sequence prediction. Okay. Style transfer also based upon, for example, you are walking and you are walking or running, or you are going very slowly, that you want to capture. Okay, so in that case, you can think about the transfer kind of thing, right? But it is a classification problem. Okay, predicting the strength of a password. A password is strong or not. So all of us know what is the meaning of a strong password. So that should be a capital letter, let's say small letter, number, special character, something like that, right? Whenever nowadays it is asking us to fix a password for 12, uh, 12, 12 digit, sorry, combination of digits and alphanumerics, right? Or special characters, right? So it is an example of classification in that context. Clustering, if you if you have considered all the passwords into a group, then only you can think about clustering. Clustering means you have to make groups, strong password, weak password. Then let's say a person is entering a password, you are mapping to either strong password or weak password. So that is a problem of clustering. So it is a problem of classification, and you can say it is a problem of regression. If you draw a particular line and let's say data points are very close to, if a new data point is coming and it is close to that particular line, then we can say it is a, let's say, strong password. So I can say that, let's say there is error is, let's say 0.2 either side of that particular line. So if it is within like lies in that range, then I can say that is my regression problem. Otherwise, it is a classification problem. Identifying a famous landmark in a photo. If you want to identify a famous landmark in a photo, like I told you, an object detection in earlier case. Okay, this is a problem related to the classification, right? So if you are given a particular image, you have to identify. So you have to classify that particular landmark from a particular photo. That's in that context is classification. And many people are saying clustering. Clustering means if you think that some landmarks are already there with you and you want to add another landmark into your group, then that is comes under clustering. But in this case, we are not doing that. So that is the reason why it is a classification problem. Okay. So suggesting spelling corrections, what we are getting in nowadays in Grammarly and other Ginger or any other applications. Spelling corrections. Sequence prediction is predicting a particular word. Sequence prediction is a particular, I am predicting a particular word. Suppose I am writing, let's say, Waranga, Warangal. Okay. For example, Warangal is a word that is given in the dictionary. So, but I am talking about the spelling corrections. I have missed some particular word. Regression, if you have correct words, yes, that is, it is also can be considered as a regression problem. That is correct. And it can be also considered as a clustering problem, because spelling these words are already there with you. It is there in your dictionary. So by looking into your dictionary only, you are doing whether it is a correct or not. Okay. So whether it is a correct word or it is not a correct word. So in that context, clustering is going to also come. Regression is also partially true. I agree with you. Okay, predicting the quality score of an advertisement. So obviously it is a regression problem, right? It is a regression problem because you are predicting the quality score. So you have to define what is quality. Okay, based on that, you have to say where a new advertisement is coming. So you have to say that what is their score. So it is a regression problem. The next one is estimating the arrival time based on the time of day and traffic, which you are experiencing in Google Map. It is a regression problem. I already told you, right? From X location to Y location, you can draw a line. So it is an example of a regression. So the last one, translating between two languages, Hindi to English, or let's say Tamil to Telugu. It is a style transfer, right? Yes, style transfer. You are moving from one language to another language. It is a style transfer. Okay. So this is all about this particular lecture. So what we have learned as a conclusion, I can say we started with a Gartner hype cycle. Then we have seen the Google trend on machine learning and data science. Then we started with what is a machine learning. We have seen some videos also. We compare a rule-based system with machine learning. I told you rule-based system is moreover, it is explicitly programmed, but machine learning is not explicitly programmed. We have seen some of the idea to implement it. We have seen an end-to-end process, starting from defining a problem, defining an objective, then building a particular model, training, validation, and testing. Then we have seen a picture where AI, ML, and DL is there. So deep learning is the core area nowadays people are focusing on, which is a narrow area. Then I have not told you about history of machine learning, but I told you some of the models related to the machine learning, I can say. And we have seen classification, clustering, regression, sequence prediction, and style transfer. We have also seen supervised learning and unsupervised learning. And I told you also about semi-supervised learning. Although in other lectures, we are going to cover these topics in more details. So that's why I have not told you in detail. Yeah, this is, I said, this is the slide given by the Google to us as a DSC facilitators. So I have taken this slide. Some of the slides I have modified, but rest of the slides is as it is with whatever available with the Google machine learning group. So thank you everyone. So if you have any question, you can ask.